Welcome back, Andy Gunawardena. Today, we will look into predictive AI, that is, building predictive models using data. In this chapter, we'll walk through a practical case study that demonstrates the power of data-driven decision-making in real estate. By the end, you'll have a solid understanding of how predictive algorithms work and how they can be applied to various domains. So, what is predictive AI? Predictive AI uses historical data to forecast future outcomes. For example, it can help us predict home prices by learning from lots of data what attributes or features of a home contributes mostly to its price. Sometimes our intuition may not be exactly right in making decisions like this. Unlike a realtor deciding on the value of a home from a few data points, we build a predictive model from data and use predictive AI to analyze a broad range of factors related to the pricing of a home, making predictions more accurate and reliable and data-driven. Here we are seeking a linear relationship using a statistical technique called linear regression that models the relationship between a dependent variable, like home price, and one or more independent variables, such as square footage or number of rooms. For example, we may say price equals minus 2 times age plus 3 times square footage of the home is what predicts the home price. A coefficient of minus 2 for age suggests that as the age of the home increases by 1 unit, year for example, the price decreases by 2 units, thousands of dollars for example. A coefficient of 3 for square footage suggests that as the square footage of the home increases by 1 unit, the price increases by 3 units. So, instead of guessing what the relationship is, our goal is to find the values of coefficients from thousands of data points. We begin with a large data set. In this data set, we have the actual values of homes in a specific region, based on factors such as income, number of rooms, population, etc. These are called independent variables, and the price of the home, known as the dependent variable. The first step in our analysis is to read this dataset, which may be available as a CSV or Excel file, into what we call a data frame. A data frame is stored in the computer's memory, allowing us to process the data to extract valuable insights. The Python code for reading a CSV file into memory is shown. You can try running this code by following the instructions provided at the end of this presentation. It is always beneficial to gain a deeper understanding of the dataset you are working with. One effective approach is to explore each of the independent features, such as income, population, or number of rooms. For example, you can analyze the maximum, minimum, and range of these features to get a clearer picture of the data distribution. Similarly, you can examine the dependent variable, like the price, to understand its characteristics, such as its spread, central tendency, and any potential outliers. This process of exploring and summarizing the dataset is an essential step for any data scientist, as it helps you develop an intuition for the data and identify any potential issues or interesting patterns. Before building our model, it's essential to properly prepare the data. This preparation includes cleaning the data by addressing any missing values, normalizing the data, and selecting the most impactful features. Feature selection is particularly important because it allows us to concentrate on the variables that genuinely influence home prices, thereby improving the accuracy of our predictions. In this scenario, let's assume we select x0 to represent the age of the home and x1 to represent the number of rooms in the house, with y being the price of the home. After normalizing the data, all values fall within the range of 0 to 1. This normalization ensures that no single feature has an undue influence on the model during training, leading to more balanced and reliable predictions. Say, we have 5,000 data points that we can divide into two sets, a training set and a testing set. The training set consists of approximately 90% of the data, 4,500 data points, while the testing set comprises about 10%, 500 data points. Our goal is to train the model using the training data and then assess its performance with the testing data. For example, if 85% of the predictions made on the testing data match the actual outcomes, we would say the model is 85% accurate. Although there are numerous mathematical concepts underlying the process of building a model from data, we'll delve into those in a future course. For now, let's approach the model as a black box and focus on understanding the broader concepts. The result is a prediction model that estimates the price of a home based on its age and the number of rooms. Sometimes the coefficients in the model might not seem intuitive, but they are what the model has derived from the data. As long as we have correctly implemented the model, our task is to interpret its outcomes. A relatively large intercept doesn't directly imply that the independent variables have limited predictive power. It simply reflects the baseline price when all features are at their baseline, zero values. Limited predictive power would be more accurately assessed through the magnitude and statistical significance of the coefficients, as well as by looking at the overall model fit, e.g., R-squared value, p-values. We will explore these concepts further in upcoming videos. Now, we can use our model to predict the price of a new home. For instance, we might estimate the price of a 5.9-year-old home with 2 rooms. The model provides us with a predicted price, which we can then compare with actual market prices to assess the model's accuracy. However, the model's output is a normalized value between 0 and 1. To translate this back into a real-world price, we need to apply the inverse of the min-max scalar, which adjusts the prediction back into the original price range. For example, if the original price range is between $800,000 and $1 million, we use this transformation to obtain a realistic price estimate. We encourage you to put your learning into practice. You'll be using CodeBench, a dynamic AI-enhanced platform designed for learning AI and data science. It allows you to experiment with real datasets and explore concepts beyond what is covered in this video. Log into CodeBench using the provided information. Please do not alter any account details, as this is a shared account among all users. Additionally, you can watch the instructional video on how to use CodeBench to gain further insights. In conclusion, predictive AI, through linear regression, offers a powerful way to predict home prices with greater accuracy than traditional methods. By leveraging a wide range of data, we can make more informed decisions. The principles we've discussed today can be applied to various other domains, such as sales forecasting or risk assessment. As AI technology continues to evolve, its predictive capabilities will become increasingly important across many industries. Now we will look at a demo of what we discussed here. After you watch this demo, practice on your own. You can also do the chapter project. Follow instructions given in the CodeBench. Thank you for watching this video.